When people talk about energy today, the conversation often turns political. The grid is broken, utilities are failing, regulators are behind. But what if the issue isn't failure? What if it's tempo? Energy infrastructure is not collapsing. It is operating exactly as it was designed to operate. The challenge is that capital, compute, and deployment cycles have accelerated, while utilities remain optimized for a different rhythm. This is not a story about malfunction. It is a story about speed, and relative speed reshapes architecture. The grid is not broken. It is functioning according to design principles established over decades. Stability, predictability, multi-decade asset cycles. Utilities were built to provide reliable service over 30 to 50-year horizons. That requires deliberate planning, conservative engineering, and regulatory oversight. The system prioritizes continuity over acceleration. The problem is not dysfunction. The problem is mismatch. When surrounding economic systems accelerate, a structure optimized for stability begins to appear slow, even when it is operating exactly as intended. The core issue is tempo. Capital accelerates. Venture capital and private equity operate in compressed deployment cycles measured in quarters, not decades. Regulation deliberates. Public process requires stakeholder input, hearings, rate cases, and review. Infrastructure lags. Permitting, environmental studies, and construction timelines extend across years. Each of these components is rational within its own logic. But when their speeds diverge, friction emerges. Energy architecture becomes shaped not by failure, but by tempo differentials. Capital today moves in compressed cycles. Venture-backed infrastructure must demonstrate commercialization within funding windows. Private equity operates under deployment deadlines tied to fund life cycles. Portfolio pressure accelerates decision velocity and reduces tolerance for delay. Financial capital can reallocate between sectors in days. When infrastructure cannot keep pace, capital does not wait. It searches for alternative pathways. This does not imply recklessness. It reflects structural incentives. Capital optimized for velocity will naturally gravitate toward systems capable of matching that tempo. Regulatory systems are designed for deliberation. Public comment periods ensure transparency. Rate cases require documentation and thorough analysis. Integrated resource planning spans decades, incorporating community review. Environmental and interconnection studies add additional time. This process is not inefficient. It is designed to protect equity, reliability, and long-term system stability. But deliberation inherently moves slower than venture deployment cycles. When capital velocity meets regulatory deliberation, the result is temporal friction, not malfunction, tempo divergence. The incentive structures differ fundamentally. AI infrastructure prioritizes speed, scale, and optionality. Time to deployment determines competitive positioning. Rapid capacity additions improve operational efficiency. Flexibility preserves strategic advantage. Utilities prioritize stability, reliability, and rate-based returns. They optimize for predictable cost recovery and minimize disruption risk. These models are not in conflict. They are simply calibrated to different objectives. When systems with different incentives intersect, architecture begins to stratify. Rate of return regulation rewards stability. Utility infrastructure is built for long operational lives, often 30 to 50 years. Depreciation schedules, maintenance protocols, and cost recovery frameworks emphasize durability. Predictable returns reduce financial volatility. Risk minimization avoids outages and regulatory exposure. This creates a resilient backbone, but it does not incentivize rapid experimentation or accelerated deployment. AI infrastructure, by contrast, often accepts higher risk in exchange for speed. These are different optimization functions, and optimization functions shape behavior. Time horizons diverge sharply. AI compute planning cycles align with product launches, funding rounds, and competitive positioning, often 12 to 24 months. Utilities plan through integrated resource frameworks extending 20 years or more. Capital can shift between asset classes almost instantly. Physical infrastructure requires years of build-out. Financial tempo and physical tempo move at different speeds. When the difference becomes material, capital seeks structures that reduce exposure to slower layers. This divergence creates structural asymmetry. Energy architecture is becoming layered. At the base sits the utility backbone, stable and resilient. Above it, private energy layers emerge, faster, modular, and flexible. At the top sits AI compute, operating at the highest velocity. This is not fragmentation, it is specialization. Each layer optimizes for a different tempo and function, but as layers stratify, influence shifts. The faster layers increasingly determine system design constraints and capital flow direction. Tempo shapes architecture. Private infrastructure expands upward through several mechanisms. On-site generation reduces dependence on transmission bottlenecks. Battery buffering decouples instantaneous load from grid supply. Private wire integration creates parallel energy pathways. These configurations reduce exposure to regulatory timelines. They create optionality. They do not eliminate utilities, but they reposition where timing control resides. When deployment velocity becomes critical, organizations build layers that move independently of slower processes. Utilities do not disappear. They become the backbone. They provide connectivity, redundancy, and baseline stability. They absorb long-term reliability obligations that faster capital cycles cannot sustain. When private systems require backup or balancing, the grid remains essential. But strategic influence shifts, not replaced, repositioned. The utility layer remains foundational, yet faster layers increasingly determine deployment timing and architectural direction. Relative speed determines influence. When one layer of a system operates at a fundamentally different tempo than others, it begins to dictate constraints. Design priorities shift to accommodate the fastest moving layer. Investment flows adjust accordingly. In energy infrastructure, this principle is becoming visible. The fastest layer sets the tempo for the entire stack. And tempo determines who captures optionality. Control increasingly migrates toward faster layers. Private operators choose when and where to build. Capital allocators decide when to energize capacity or pivot strategy. Modular systems preserve flexibility to integrate new technologies. Utilities maintain reliability, but timing control, the ability to accelerate, shifts upward. Timing control shapes influence, and influence shapes capital allocation. Capital follows velocity. Institutional investors increasingly favor infrastructure models that reduce regulatory friction. Modular, scalable designs attract funding because they compress timelines. Factory-built components reduce on-site risk. Behind-the-meter configurations limit exposure to prolonged public processes. Speed compounds. Each deployment cycle completed while others wait for approvals generates data, experience, and market positioning. Velocity becomes an asset characteristic. Certain profiles benefit structurally. Modular developers capable of repeatable, rapid deployment. Private infrastructure operators who manage timing strategically. Strategic capital that understands tempo dynamics. Returns in these models are linked not only to energy production, but to deployment velocity. Architecture matters, and architecture evolves toward the fastest layer. This is not a failure story. It is structural evolution. Utilities were optimized for an era where capital, regulation, and infrastructure operated at similar speeds. Today, those speeds diverge. Layering is a natural response. Private and public infrastructure become complementary. The system adapts. Understanding that this is tempo divergence, not dysfunction, matters for capital allocation and policy design. Public debate often focuses on blame, grid failure, rate disputes, political narratives, but beneath the surface, architecture is evolving around tempo. Capital is reorganizing energy delivery structures to match deployment speed requirements. Operators who focus only on surface debates may miss deeper repositioning. Architecture evolves regardless of political framing. Structural change occurs quietly, through capital flows and deployment decisions. Tabis publishes systems-level analysis for operators, investors, and capital allocators navigating layered energy architecture. Our work focuses on incentive alignment and structural evolution, virtual power plant architecture, negative load infrastructure, and so on. Public narratives debate outcomes. Institutional advantage requires understanding structure. If this framework resonates with how you think about infrastructure, you already understand why deeper analysis matters. See you next time.